All right, Honors Algebra 2. Here we go. Finding general answers. Okay, I hope you have watched the video that had the explanation of general answers in it, because we're going to refer back to that and use that, what we gained there. And we're also going to look at one other example of a different type of a general answer. Okay, so we got to solve 2 times the cosine of x equals the square root of 3. We still solve it like we have been. So we divide by 2 and we get cosine of x equals square root of 3 over 2. Now again, when you see those square root of 3's and those 2's in there, maybe we should be able to do this without a calculator. And we can say what? Again, it's a cosine, so we want an adjacent of a square root of 3. So if this is my angle here, and I put a square root of 3 there, and we want a hypotenuse of 2, well, what angle would this be right here? It would be a 30. There would have been a 1 over here. Up here there would have been a 60. So we get a 30-degree angle. All right, so if you can't remember that and you punch it in your calculator and you say inverse cosine of square root of 3 over 2, your calculator will say 30 degrees. Now if we're doing it in radians, at some point in time here, we've got to switch that over to pi over 6. Okay, again, remember my little trick, 180 divided by 30 gives me 6. Then what do? Then we say this is a positive number here. Square root of 3 over 2 is a positive. Where can the cosine be positive at? All students take calculus. Well, that's the first quadrant and the fourth quadrant. So we put a pi over 6 reference angle in both of those quadrants. And we get answers of pi over 6 in the first, and this would be 12 over 6 minus 1/6 would be 11 pi over 6. Now we saw in our explanation of general answers that we were kind of always looking for, do we have a straight line here and we added 180 or added pi? Well, we don't have that here for either one of these. Okay, we don't have this angle over here. So we're not adding pi or 180 degrees. We're also not adding 90. All right, so normally for this pi over 6, we would have just said, hey, that answers pi over 6. But now we have to represent every other coterminal angle with that, which means we've got to continue to represent adding 360 each time and subtracting 360 each time. All right, let me get rid of all those arrows. But since we're in radians, we're not adding or subtracting 360. We're going to add or subtract 2 pi, and we do it k number of times. Remember, your k is any integer. So, negative 2, negative 1, 0, positive 1, positive 2, and so on. So that takes care of pi over 6 and every other one of its coterminal answers. Then we do the same thing with 11 pi over 6. Since we're not adding 180 and getting an answer over here, we have to go all the way around to get back to it. We're adding 2 pi k amount of times. And these two answers are general answers. There's no restrictions, or those aren't answers between 0 and 2 pi, or 0 and 360. Those are every possible answer. So if you think back to those coterminal problems we did and how we can continue to go around 360 degrees and land back at the same spot, therefore we always have the same reference angle. Okay? So these are all of the possible answers from negative infinity to positive infinity, actually in radians. Those are the general answers for that problem. Okay, on number 2, one thing I want to point out here, when you see different trig functions in here we have tangent and cotangent. I always say you have to separate them, okay? So if we were in algebra and we had x equals y times x and we were going to solve this, we would subtract that x over, then we could factor it out as a GCF. So we've taken our x and our y and we've separated them. They used to be multiplied together right there. We separated them, okay? We're going to do the same thing with this tangent and cosine in this problem. We are going to subtract our cosine over so that we have it equal to 0. And then we're going to factor it out. And that has gotten our tangent and our cosine away from each other. You can think of it that way. This part only has a cosine in it. There's no tangent in that part. This part only has a tangent in it. There's no cosine. And then we just set them equal to 0 like we were in algebra, and we're going to start to solve these. Okay, so let's go with the cosine. Go over here. Cosine of x equals 0. We're going to solve this. Now remember, when you're doing a sine or cosine, especially when you're equal to 0, 1, or -1, think coterminal, or excuse me, think unit circle. Okay, and cosine is equal to x. So this is wanting to know on the unit circle, where is x equal to 0? It's equal to 0 right there at 0, 1, and down here at 0, -1. All right. Now, let's use degrees here to help ourselves out. That's 90 and that's 180. So notice, how do I go from that answer to that answer? I add 90 degrees. Excuse me, add 180 degrees. Oh, messed up. This is 270 down here. So to go from here to here, we're adding 180. All right? And then to go from 270 back up there, we would add 180. Sometimes it might help you to think about things in degrees whenever you're trying to write your answer in radians. Now just switch your thinking to degrees. So we can start at 90, which is pi over 2. And how do we continually get to the next answer in line? We start adding 180, which is pi. Then we could have also went the other direction and been subtracting these 180s. Okay, so we would have been subtracting pi's, but we don't write a subtraction. We say times k, and we know that k can be any integer, which is all these integers on the negative side of 0 and all those integers on the positive side. So these take care of the negative direction. Okay. Now for the tangent of x minus 1 equals 0. Let me clear out some room. I'm going to leave that answer there though. And I'll tell you what. I'm going to write it up here. Pi over 2 plus pi times k. So we've got that answer so far. Now tangent of x minus 1 equals 0. We would say that means the tangent of x equals 1. So again, that's an opposite over adjacent there of 1 over 1. Where does that happen? Can you tell me before I write it in here? 45. Opposite of 1, adjacent of 1. So if we were to type in our calculator, tangent of x, inverse tangent, making all kinds of mistakes this morning. Inverse tangent of 1, the calculator would say 45. All right. Now, it's also a positive 1. So where does that happen for the tangent? All students, won't happen there. Take calculus, won't happen there. It happens in the first and the third. All right. Now, if we're in radians, we're not going to think 45. We can think 45, but we got to write pi over 4. So this first answer is pi over 4. All right. What's this second one? Let's think degrees. This one's 45. This one is 225. Well, look again. We add 180 to get there. All right. Or you can say, how do you go from pi over 4 to 5 pi over 4, which is what this one would be? How do you get from there to there? 5 pi over 4 to pi over, you add pi. All right. So then what would go ahead and try to think of what your general answer would be for this. What would we say after pi over 4? We would say plus pi times k, and that represents this first quadrant answer of pi over 4, adding 180, getting the 5 pi over 4, adding 180, and since k can be negative, it's just taking care of subtracting the 180s or subtracting the pi's all the way around. So we have two answers to this problem in general answer form. Okay, hope that makes some sense. Let me know if you have any questions. Google Hangouts again, I've always got that on, and we can take care of them. All right, we'll talk to you later.